Hi Professor, this is Dan Riseman with assignment 1.3. For question number 9, given a line and a point not on a line, there can be infinite line segments drawn that connect the point to the line in 2 space and in 3 space. And I diagrammed it here below for both. For part B, given a line and a point not on a line, only one line segment can be drawn that connects the point to the line, so the segment and the line are perpendicular in both 2 space and 3 space. Again, I diagrammed both for us. Number 11, two parallel lines define a plane because these two lines are equidistant and remain at a constant distance for an infinity, thereby forming a flat area that can extend infinitely in 4 directions to cover that area between the two parallel lines. I had an analogy, the idea that you have two parallel bars, you can rest a flat poster board on those bars, and theoretically that surface could stretch on infinitely, and that would be a unique and plane defined by parallel lines as demonstrated here below. For number 13a, what happens here is a little bit trickier. You have your points, let me get it for us a little bit more so. If you have two skew lines, define a 3 space. Let me show you. Here we go. So two skew lines defining a 3 space. So if you had it, this is true because if you have these skew lines, they're never going to intersect. And what you could do is you could pick 2 points from each line, and they are non-coplanar. And because 4 non-coplanar points define a 3 space, you'd have a 3 space. For part B, one plane and a point not on that plane. So here's your plane and a point not on it. For example, let's say there's a point up here. What would happen here? This is true because one point is not on the plane, where you could pick 3 points here and then 1 point here, and you would have a 3 space. For letter C, 2 parallel lines and a point not on either line define a 3 space. Well, if you had 2 parallel lines and you had a point, so let's say here, in the 2 parallel lines, this is not necessarily true because the parallel lines form a plane, and if that point is on that plane, then all the points are in the same plane, and this will not be 3 space. And for D, 2 intersecting lines and a point not on either line define a 3 space. This is not necessarily true because the 2 intersecting lines form a plane so that the point lies in the same plane. If it does lie in the same plane, that point, it would not define a 3 space. So that was for 13. So for 16, 4 non-coplanar points define a 3 space. I did a demonstration here, right there. And with one plane, for B, one plane and 1 point not on the plane, you can pick 3 points on the plane that are not on the same line, and since the other given point is not on the plane, you have 4 non-coplanar points, which defines a 3 space. For part C, with 2 intersecting planes, you can pick 3 points that are only on one plane that are not on the same line, and one more point that is not on the other plane, resulting in 4 non-coplanar points, which defines a 3 space. For D, with 2 parallel planes, you could pick 3 points from one plane that are not on the same line, and one more point from the other plane to get 4 non-coplanar points, which defines a 3 space. And with 2 skew lines, you can pick 2 distinct points from each line, and you will have 4 non-coplanar points, which defines a 3 space. For 17, it took me a while to think about this one. It was tricky. But in a 3 space, the 2 lines that are perpendicular to a third line do not have to be parallel, because you could have a line in 3 space and a plane that is perpendicular to that line at any point. In that plane, you could have 2 lines that lie in the same plane that are not parallel to each other, but since they are both in the same plane, they are both perpendicular to the line that the plane is intersecting.